Question 5, a nice little 2 marks here, and it's just worth going over a little bit of further calculus. We'll just talk about trig for the first bit. So you're given this, so there's not a huge amount to remember, which is good. What this is saying here is that if you differentiate sine, you're going to get cos. And if you differentiate cos, you're going to get negative sine. Very good. So that would mean then if I differentiate negative sine, I'm going to get negative cos. And then that pattern just kind of repeats itself forever and ever. So up here is the negative sine, negative cos. That's the end of our pattern. And then down here we'll have the sine and cos. That's the pattern repeating itself. Yeah, so that represents differentiation. And going the other way, just see that in the video, would be integration. So that's what this is telling you first of all. The other thing to note is the a value. So this is saying if you differentiate, you are multiplying by the differential of the bracket. Okay? So if I've got something like cos 2x and I want to differentiate that, well, what does cos become? Cos becomes negative sine. The 2 stays the same and I'm multiplying by the differential. Okay? So if I differentiate, I'm multiplying by the differential. That's what this bit's saying. And this is saying if you integrate, you divide by the differential of the bracket, which is very similar to the chain rule for complicated functions as well, your composite functions, sorry. So if you get that sorted out, that's the first bit. So let's have a look then. If I've got the integral of 8 cos of 4x plus 1 dx, and don't forget with your integral sign and dx, make sure you have them. If I integrate that, okay, so cos is going to become sine. I'm going up there, become sine. So I would just write that down. And your bracket stays the same. Don't forget your plus c. Now the 8 also stays where it is. However, I now need to divide by the differential, which is going to be 4. If I differentiate this bracket, I get 4. So to simplify that, I'm going to have 1/2 sine 4x plus 1 plus c. And that's a nice 2 marks. Sorry, not half, 2. What am I thinking? Thinking 2. 2 signs round. So yeah, that's a nice 2 marks. So when you do these, you don't have to stress about remembering because you're given that table. So you should know what sine and cos will become if you integrate and differentiate. And if you just remember this little bit, that's fine. And yeah, this is giving you a clue that you're going to multiply by your differential, and here you're dividing by the differential, and that actually then feeds into your chain rule as well. So if I've got y is equal to 4x plus 2 cubed, and I want to differentiate that, okay, well we treat the bracket like it's, if I was to say if we do y is equal to x cubed, what do I get when I differentiate that? Dy by dx, that's just going to be 3x squared, isn't it? So it's the same here, it's 3, the bracket stays the same, squared, but then we multiply through by our differential, which is what this is telling us. Okay, so when we've got our composite functions, we can use these tables to remind ourselves what we're doing it. We're multiplying and dividing. And likewise, if I was integrating that function, I would do the exact same thing. I would say, okay, if I've got y is equal to 4x plus 2 cubed, and I want to integrate that, so I'll just say the integral of that. I'll take out the y just now. So the integral of that, well, same again, what if I had the integral of, we'll call it u, okay? Well, the integral then would become add 1 to the power, divide by the new power. And that's the same here. You'd say, okay, I'll add 1 to the new power for 4 and divide by the new power. The bracket stays the same, but I also have to divide by the differential. So this 4, the differential pops up on the bottom. So that's there in the front of your paper, just to remind you of your composite function, further calculus, integration, and differentiation as well. So it's quite a nice question to get when you get a further calc question, because you're given this. So it reminds you to do your plus c, and it reminds you that you're differentiating, you're dividing when you're integrating. Okay, so hope that was helpful. And just this little bit in here for your functions as well. Remember, it's kind of given to you at the front. That's my main point there. Okay.